to another episode of Cranes and All. In August 2019, Fulton Hogan decided they needed a Tadano tracked crane for their Waimea Dam operation up into the hills behind Brightwater, south of Nelson. This was the beginning of their project. The Tadano needed to be taken apart, loaded onto several transporters and taken to the dam site. In 2019, Fulton Hogan were in the process of building an access road to the site, so when the transporters turned up, they were still in the process of doing that. So in order to get the transporter onto site, a bulldozer was used to tow them up to the site that will become the administration area. Once there, they put the Tadano together and did a few practice lifts. They also needed to check that the Tadano crane was capable of accessing different areas around the site, so it went off under its own power to check that it could do that. No problem. So they began building the dam around 2019 after much investigation of getting the site right. The dam isn't a hydro dam, it's being built to ensure a continuous water supply for the Nelson region. So let's come forward to 2022 and have a chat to Fulton Hogan's construction manager. Well, with me is Matt Loach, and welcome to our little show, Matt. And thank you so much for allowing us to come onto your dam site. And this is an enormous project as far as I can see, and it's to do with the water and the water supply for the Nelson Tasman district. Maybe you could just explain just a little bit about how that works.
Yeah, so back in the early 2000s there was a pretty severe drought in the Tasman region in the Waimea Plains, and it really put a need for a secure water source for the district, and so the heads got together and came up with an idea of building a dam up in this area, and a few years later they found a good site up here in the Lee Valley. So we started construction in 2019 and are due to finish within the next year, and that should secure the water for the region for about 100 years or so.
Okay. Yeah. Well, that makes a lot of people happy, I bet.
Yeah, definitely. Yeah.
Absolutely. Now, you explained to me how these slopes and the rock face and the overflow, or where all the water goes down. That must have taken a hell of a lot of thought for the people who have come up with how this whole thing is built.
Yeah, that's right. So there's been a lot of design work go into the project, a lot of iterations of the design to get it right for the topography and geology here. So the design's been basically come to fruition over the last 15 years and really been nailed down over the last year or so.
So when you started, did you have we're going to be using this much concrete, this much stone, this, as a calculated guess, I suppose, in 2019 when you started? So how's that gone? Yeah, so the project has grown since we started, mostly just due to the geology here. There's been quite a bit more concrete installed. We just cranked over 20,000 cubes this month, and we've probably still got another 5 or 10,000 to go. We've moved about 1 million cubes of rock out of the dam area, and put in another 700,000 or 800,000 cube of rock to fill the dam back up. So it's certainly been a big job in what's quite a constrained area up in the Richmond Ranges here, and been a real challenge for the team. Well, I noticed that our show is about cranes, and you've got 1, 2, 3, 4, 5 major cranes, and I guess you've got a whole bunch of little ones that buzz around the place doing little jobs as well. This one down here, this great big green job, just maybe explain that to me.
Yeah, so the crane down here is a 180 tonne crane that we brought down specifically for the concrete face works. This was brought down from Auckland just before Christmas and assembled when we got back in the new year. Yep. It's a really interesting crane to manage for us because it is sitting right down in the floodplain, and this river has a very short time of concentration, so when we have a flood it comes up very, very quickly. So we have got to track it up and out of the reservoir. So it's got the longest stick we could put on it to reach that concrete face, because the crews here have got about 4,000 cube of concrete and about 400 tonne of steel to place on that steep slope. The idea of the crane is to get all that gear right up close to them so they don't have to be working too hard on that slope on the ropes that they have to work from.
So what it's lifting is a concrete bin?
Yeah, so today we'll be lifting a concrete bin or skip. we'll be skipping a large part of the concrete on that face, that 4,000 cubes over the next 3 or 4 months.
Right.
And also it's lifting in the formwork and the steel for the steel fixes.
So as that pour gets sort of up here, the boom will come out of it.
That's right, yeah. So because of the angle of the face, you can imagine that the boom can only go so low before you run out of headroom.
Oh, yes.
So that's why we added on the fly jib, because it just brought us a bit of extra distance without actually impacting on the headroom of the lift. So that crane can lift all the way up here with sufficient headroom to lift most things, as long as the dimensions aren't too big.
Right.
But it does, it doesn't have a huge. It only lift about a half a ton by the time it gets up to the top. But that's enough for a lot of the things we're doing, like smaller steel bundles and generators and bits of formwork and things.
I'm just thinking, 2 cubes at a time is going to take a while to fill it all up.
That's right. So ideally, what we would be doing is starting the pour with a concrete pump.
Yes.
And that'll speed up the priming of the slip former, and then the initial part of that slip forming process. In this case, we just can't reach with a concrete pump. It's just too far away for even the largest concrete pump in the region to reach. So we'll skip that in. And for these larger slabs, you can see here, we'll start with the concrete pump, then we'll use the crane in the middle where the pump can't reach, and then we'll set the pump again up at the top.
Wow. It's a hell of a lot of wire rope.
It is a lot of wire rope, just because it's such a long boom. I know when we were up here the other night to move the crane out of the river, because there was so much rain, the top of the dam here was actually in cloud, and so we couldn't see the top of the jib, and we were just trying to find out where the hook was, because we were wanting to move some steel out of the road to shift the crane. And so we're looking up in the clouds, and all of a sudden there's this hook emanating from the clouds. Yep, so he's slowing around now. Yeah, it's quite eerie. You imagine you're looking up at the clouds and the hook starts coming down through the clouds at you. Just gives you a scale of the height difference between the bottom of the dam and the top. Bit of wildlife.
A bit of wildlife leather, yeah. They taste alright, don't always.
Well, the chicken likes them. The chicken down the pig.
Oh, okay.
We've got a resident chicken in the pigs as well. They were wild pigs, but we're up to generation about 5 now, and they're pretty tame. The other thing too, you get a lot of goats coming around this slope.
Okay, just hanging on them.
Yeah, but you can see we've got guys working over there, and they kick rocks down, so we've had to cull a few of them, stop them kicking rocks down on the guys.
So on a really windy day, would you work? I mean, that must be swinging everywhere.
That's right. So yeah, we try and avoid complex lifting when it's really windy. In this case, you can see, it's even challenging when it's not that windy, just because of the blind lifting. And the guys have got to dial each other in. So being the first lift, the operator and the dogman and the guys on the ground will be dialing each other in. He'll be getting used to exactly where that slip form is sitting in regards to his slew and his luff, and then the guys will start dropping the concrete in. So after 2 or 3 skips, they'll have it dialed in, and it'll be a lot faster. But you can imagine in the wind, the guys are really having to grab onto
the ropes hanging.
Yeah.
Stop it from swinging.
That's right. They have to.
And it's not a light thing at all.
It's not. No, they have a fair bit of mass to them.
Yes.
Which, I mean, it can be good and bad, because the heavier the lift, sometimes the less impact the wind has on it. But unless it's of a big dimension, these concrete skips are pretty dense, because they're quite small dimensions but quite heavy, so the wind doesn't impact them, say, as much as a large piece of formwork, which can definitely flutter around a lot in the wind. So when we analyse this operation, we're looking at everything. We're looking at how many seconds does it take to fill the skip up, how many seconds does it take to slow the crane into place, how many seconds does it take to dump the load of concrete out of the skip, how many seconds does it take to slow back to the concrete truck, because we need to find ways to fine-tune it. Yeah, find any number of seconds in any of those processes, because if you can imagine, if you're going to place 4,000 cubic metres with a 2 cubic metre skip, that's 2,000 loads of concrete. So every minute you save on a
lift and a pot.
On a lift is a huge gain to the operation.
Wow.
So this first slot, as I say, when they're priming the slip form is a bit of a slow operation because they're trying to get the concrete in a very exactly where they want it, which is underneath the slip former.
Yes.
And then as the slip form is coming up, the concrete's placed actually uphill of the slip former itself, so they can just dump it on the ground. So it's a lot faster to actually get rid of it.
Wow. So how many cubes of concrete in the whole episode, did you say?
So this pour here is 300, so it's 150 loads. This one here is closer to 500. But the whole face is about 4,000 cubes for the whole concrete face.
What's the big box?
It's a pump. That's a 6-inch pump. So that pumps water from different parts of the dam. In this case, it's pumping it out of the so it goes across the river and into the corner.
Yep.
Because of the drilling operations we have for the grout curtain, it's a water hammer, so the type of drill, it's operated by water as opposed to air or anything else.
Sure.
And so there's a lot of water that comes down, so it gets ponded down the bottom and then pumped away and then into a sediment pond. So you see every bit of water that comes off this job flows into a sediment pond, so the river's always really clear from the rain. The work site doesn't have any runoff, and we actually we got highly commended, which is essentially second place in the Australasian Sediment and Erosion or Erosion and Sediment Control awards. So that's projects in Australia and New Zealand for sediment and erosion control. We come second place. So
that's amazing.
Yeah, so it just goes to show, how well managed the sediment and erosion control, which is really one of the biggest, if not the biggest, environmental impacts of the construction project would be sedimentation of the river during construction. We've really avoided any risk of that happening.
So the lake size at the end, sort of over.
Yeah, I think it's about 7 kilometres long. So it goes
17.
7 kilometres long.
7.
So it goes way up past where we can see. There's also a valley to the left called Waterfall Creek, and it goes right up there as well. So in total, you should be looking between 12 and 13 billion litres of water.
Billion, that's a good number.
It is, yeah. It's a lot of water. But a dry summer, you near use it all between the irrigators and the town supply.
So when you got there here down from Auckland, it would have been on about 4 or 5 trucks?
Yeah, it was. It was on a significant amount of trucks. I think from memory it may have even been about 10 trucks to get it down here, because of the amount of stick. So normally it would be about 4 or 5, but because of that 75 metres of stick plus the fly jib, it was another 4 or 5 trucks loads to bring it down here.
So the operators, are you operating like a joystick and a computer in front of them, telling them what things weigh? And
yeah, that's right. Yeah, it's a pretty modern crane. I think it's around a 2012 or 2011 model. So it has got all the mod cons in it.
Sure. Wow. Tadano have been building cranes since 1956. Tadano is the name in mobile cranes, from 2-axle to 7-axle cranes, as well as track cranes. Tadano, a great choice of crane. So if you're looking for a crane, why not choose Tadano? Tried and true. To find out more, just go to allcrane.co.nz. With me is Tim Elliott from Kepler Motors in Hamilton. And good on you, Tim. Maybe tell us a little bit about the vehicles you sell.
Right, well, we've got an absolutely amazing range from the GWM Haval product lineup. We start with a small SUV with the Jolian, and we start from that at $27,990 plus on-road costs. We then go through that range. We have 3 models in the Jolian range. We then go into the H6, which is the next size up, your mid-size SUV, and that we actually have 5 models in that range.
Wow.
Yeah, starting from $33,990.
Yeah.
So when you look at the value for money in our range, And we even have right through to a hybrid, like our new car behind me here. As well as the SUVs, we have a stunning lineup of the GWM Cannon, which is New Zealand Autocar Magazine's Ute of the Year for 2020.
Wow.
Not only has it come up Ute of the Year because of its build quality, ride quality and safety, now 5-star safety rating in 2021, it is an absolutely amazing package. You don't get the harsh ride that you traditionally get in a ute, but you get all the safety and benefit of having 3-ton towing capacity, up to a ton payload in the back, but also room for your guests in the back of the vehicle if you're taking a few along with you.
With a bit of legroom.
With a bit of legroom and vents in the back so they have actually get a bit of fresh air as well.
Oh, that's marvellous. Get hold of Tim and I'm sure he'll look after you.
Look forward to hearing from you.
Fassi, an extraordinary crane manufactured in Italy. The amazing breadth of the Fassi range with over 30 models and 300,000 configurations means the cranes offered can be truly purpose-built. Tailor-made to suit the needs of the customer who chooses Fassi products mainly for their quality and fittings. So when choosing a crane, why not choose Fassi? You'll be glad you did. And the one behind us here, the yellow job, what does that do?
So that's an 80-ton crane that we've been using on the job for some years now, and that is mostly used for skipping concrete in the upper spillway area and also for the formwork. And that's just handy for us because it's a nice small crane, it fits into that tight area.
Right. And there's another couple of cranes just over there.
Yeah, so we've also got a 180-ton crane that's really been the workhorse for the lower spillway area. That's placed to date probably about 4,000 cubic metres of concrete on the spillway, from the mass concrete on the flip bucket through to the slip forming systems that we've been using since March last year.
Cranes have certainly come a long way. I mean, the guy sits there, he's got a computer, he's got a joystick, and that's just all done by feel, really. The computer's telling him how heavy things are and where he is, you know, in relation to where the boom is and all the things that can't go wrong.
Yeah, that's right. I mean, we've got probably a bit of a mixture of generations of crane here. So the one that you see, the 180-ton orange crane, is a crane from the 90s. It's a what we'd say earlier technology, same as the 80-tonner. Some of them have joysticks and some of them have levers, depending on the exact model. And there's less automation in those systems. They have they have load indicators for the hooks, and they indicate at what reach the boom is lifting. Whereas the newer generation cranes, such as the Tadano we have here, do a lot more than that. They'll tell you how much stick you have out. They'll tell you all the boom deflections. They'll also tell you how much the tracks in and out, because that Tadano, you can have one track in and one track fully out, or both tracks partially in, depending on how much width you've got.
Sure.
So the computer in that Tadano is a lot more complex. It's also a single joystick system, so the whole system is controlled by a single joystick, or a twin joystick control, versus the levers for say tracking on the older cranes.
Wow.
And it also lets you know what angle the actual crane is sitting on too, so it can automatically adjust the lift chart to the situation you're lifting in, for the track and for the crane pad angle.
Wow.
So this certainly a newer generation makes them a lot more complex.
Sure.
But allows you to do a lot more as well. Yep. So we just have a guy on a whistle letting everyone know that there's an overhead load coming, because the area, it's not so much today, but the area can get quite congested below where the cranes are working.
Sure.
Especially in that cut-off wall plunge pull area. So we want to let everyone know that there is a risk of an overhead load, and to look up. Yeah, so what we do, we have a dogman at either end of the load, so there'll be one at the truck, loading the truck and talking to the operator and the second dogman, and then that's right, there's another dogman right at the top of that pull. You can see him leaning back with his hand on his chest on his radio there, top end, looking up now, and he'll be guiding it in, because a majority of the lifting we do on this project are blind lifts, so radio communications are really integral part of controls.
So this crane, they're all working, sort of got their jobs to do, and they've all got their little crew that help them do that.
That's right.
And so they're all independent of each other. So
yeah, they are. They're all independent. They all cover their own work area, and they all do something just a little bit different.
Right. I see you've got a Tadano here that Mike Morris. Just tell us the significance of that. Why is that so useful?
So this is certainly the most unique crane on the project. It's a 120 tonne Tadano Mantis crane built in the USA, and the great thing about this crane is it's very compact for its lifting capacity. So it's 120 tonne, it's got a hydraulic boom, and it also means that we can really bring that boom down when it's windy, or if we need to get it under some trees or track it up a really steep slope. It also means the tracks can come in really narrow, and it can still track with all that boom still there and fit into a really small area. It is a really interesting bit of kit. It's got over 300 lift plans in the book for it, just because there's so many different configurations that you can set it up on.
Wow.
It can even lift on a 3 or 4 degree slope.
Is that right?
Yeah.
So you must be pleased with that then.
Yeah, we are. It's certainly when you're up in a challenging work site like this with, as you can see, big heights and big slopes.
Yes.
You certainly need a piece of equipment like that just to get the job done.
Sure. The slipway, you were saying before, when the water comes down, it gets buffeted, and which stops the major flow and over that.
Yeah, that's right.
Maybe just explain that too.
Yeah, so this is one of the steepest spillways in the country.
That's the ramp that the water's coming down at 100 miles an hour, stopped at the bottom by that curve.
Yeah, that's right. So the water will come down that spillway. It's on a 1 to 2 grade, so pretty steep, and then it'll hit that flip bucket at the bottom, and it'll jump up, and it'll be entrained with air as it passes through the air, and that'll dissipate the energy out of that water, and then it'll just plunge into the area below. So you can see where there's a bit of a road and some pumps.
Yes. All
All that area will be dug out into a large plunge pool, about 8 or 10 metres deeper than where it is now.
Sure.
And that'll just be a permanent a pool of water to help dissipate that energy.
So what happens to that water? Does it just head off down the river?
Yeah, that's right. So when the spillway is spilling, it'll go into that pool, and there'll be an outlet at the bottom of the pool, and it'll just be part of the natural river flow.
Sure. So tell me, how is the water stored behind the dam? That's the important stuff.
Yeah, that's right. So during the winter, the water will be stored in the dam. It's envisaged that the spillway will be spilling a large part of the time through winter.
Yep.
And then the dam will be drawn down through summer through the tunnel structure you see below us,
yes,
where the river's currently flowing, and that'll have some pipe work and inlets that run through the tunnel and into the upstream concrete face part of the dam, and they'll be controlled remotely from town or from the Richmond area. And based on how much flow they want into the river, they can control the valves to increase or decrease that flow.
Tadano have been building cranes since 1956. Tadano is the name in mobile cranes, from 2-axle to 7-axle cranes, as well as track cranes. Tadano, a great choice of crane. So if you're looking for a crane, why not choose Tadano? Tried and true. To find out more, just go to allcrane.co.nz. The Gecko mini crane without riggers, designed to get into small areas and confined places like stairs, passageways, things like that. Because they don't have a huge setup time, this saves money and time. Gecko, the crane that does all those little jobs in tight places. For more information, check out www.allcrane.co.nz.
So as the water comes down, it'll hit the flip and jump into the air, and then enter the plunge pool where all the energy is dissipated.
Okay, and that must, even just that must take some thinking about. How are we going to stop this energy from sort of causing damage as it goes down?
Yeah, definitely.
I know, I've got an idea. Let's just put a buffer in.
Definitely. I mean, the engineers have really been challenged in getting the spillway and the rock to work in together, and there's certainly been some major concrete going in the hole to protect that rock from eroding away.
Yeah. I see you've got piles of rock over there and more over there. Is that all just local rock, or is it carted in? Or?
Yeah, so about half of the rock in the dam itself has been sourced from site, and the other half's been imported from further down in the valley. And the reason is because of the different zones of rock in the dam. We need different characteristics for the rock. For the main fill, it's okay to use the Site 1 material, which is a little bit softer.
Yes.
And then at the extremities of the dam and in the base, we want to use a very hard rock. So we go to a specific quarry down the valley, which has a hard rock source, and we've been importing that. It took about a year or so to import that with trucks.
I just see all these rocks on this face here. This looks similar to what the Matahina Dam is. It's got a whole rock face facing, after the water's, well, all the water comes down on one side, but it did crack or leak or something happened to it.
Okay.
But I see this is similar to that, all that rock face there.
Yeah. So when we started building the dam, there was a risk that the dam would overtop during a flooding event. So we built what's called a reinforced rock fill, which is essentially the embankment is reinforced with steel and anchored into the bedrock. And what that means is if the dam overtopped, all that reinforcing would hold the embankment together, and it wouldn't collapse under the flood flow. Right. As we've worked our way up, the risk of overtopping is diminished to virtually zero, and so that reinforcing stops. But what we do see is left is this large rock facing or armouring on the dam, and that avoids any erosion from rain over the long term.
Oh, okay.
And just provides a nice solid facing for the dam.
Sure. So if you compare this to, say, the Benmore Dam and those southern dams, how does that sort of compare?
Yeah, so definitely, certainly not on the size of the large Waitaki scheme dams. Although it is technically just as complex, and that's because of the topography and also the design of the dam being concrete face rock fill dam.
Yes.
It's quite different to those large earth embankment dams.
Well, yeah, we did on our previous shows, we've done the story of building Benmore, building Waitaki, building the Aviemore, and it's absolutely fascinating. But again, they haven't got the equipment that you have today. Back then it was a real challenge, I would say. Yeah.
Oh, definitely. Those guys, that was their life, building those dams. They built the towns of Twizel and things like that for those projects, and those people lived their life breathing and living the dams. And it's what's made New Zealand what it is today, having those large infrastructure projects. And I mean, whilst this is a smaller scale to those projects, it certainly will have a similar impact on this region. Look, I just think it's been a real challenge for the team to build a project of this scale. It's been such a long time since we've done a dam of this size in the country, and it's great to see that with two Kiwi companies, Fulton Hogan and Taylors, have been able to come together and build the project, and given it such complexity.
Oh well, thank you so much.
No worries, Bill.
There you go. It's Matt, and he's the project manager, I guess. Is that your title?
Construction manager.
Construction manager. So what he doesn't know about this place isn't really worth knowing.